Hello, I'm Michael Stock with Ocean Conservation Research, and thank you for your interest in this contentious issue. I think one of the reasons why it's contentious is offshore energy is moving really fast right now, and there are a number of inimical forces who either don't understand it and are afraid of it, or they are deliberately trying to get in the way because they see it as competition, et cetera, et cetera. So, but what brought this up is I was asked to review an unusual mortality event that happened between December 22 and March 23, off of the Long Island and Jersey Shores area. I was initially reluctant to get into it because of the contention, but as I looked under the hood a little bit, I realized that there was actually something to at least inform the discussion. So most of these animals had evidence of ship strikes. That's what happens when, of course, a ship hits a whale. It's unlikely that the ones that did not show evidence of ship strikes were killed by sound directly, but there is lots of evidence of animals who are, through behavioral responses to noise exposure, end up running afoul. And so, in any event, what was happening here is these mortality events occurred concurrently with surveys taking place for offshore wind projects, and these were the wind projects that they were surveying for, and there were 14 different survey projects that were issued incidental harassment authorizations. And to review these IHAs, here's an example here of some representative equipment that would operate in frequencies below 180 kilohertz. That's kind of the high end of the dolphins and porpoises. Most of all the animals involved in this particular event didn't hear up to that at all. In fact, these are the kilohertz range that they could hear in. These one below, and the noise levels are pretty high. But that being the case, because the pulse rates were just in the millisecond range, the actual sound exposure energy, we call sound exposure level, was still below regulatory thresholds. And but here's another component of the thing which wasn't really in the mix, and it had to do with the fact that the repetition rate was in the top one, it's every half second, and the next one down is 2.5 seconds. The third one down, third and fourth one down, it's 10 hertz, 10 cycles per second. And what my Cameo is covering is all the way up to about 40 hertz, which is a tone we can hear. And even though they might have been frequencies above that, like we'll find in this next setup here, they were nonetheless popping away. So this top 4 lines here are signals that are outside of the hearing range of the baleen whales that were subject to this tragedy. They did have some. These are basically sub-bottom profilers, which were able to, I should say, they're longer wavelength and they're slower in frequency. They kind of get what's below the benthic floor here. And again, these are very high sound levels, but because of the pulse duration, the sound exposure level was also, again, below regulatory thresholds. But we also have this repetition rate thing again here. So in this case particularly, if you listen to dolphins, they will have these squeaks and squeals, which are social signals that they use, but they also have these buzzes and pops. And those are the biosonar signals that these animals use. So if you record those and kind of expand it out a little bit, they may be popping or buzzing out these signals that are essentially bundles of higher frequency biosonar signals. And so those are actually making noise even though the frequencies are above what we can hear. We can hear them making the noise. So that is the challenge I think we have here, and why I thought it might be good to excavate this a little bit. All survey efforts were occurring concurrent with the unusual mortality event, and Uh, I think that if you listened to any one of these, you would hear all this popping and banging and pinging and squealing going on. But if you had all 14 of them going on at the same time, it might have posed a behavioral problem with, well, it's kind of like in my neighborhood. If my neighbors are blowing off firecrackers, it's one thing I can leave the neighborhood and get away from it. But if I leave the neighborhood and go into town and find everybody's blowing off whatever, and then if I were a whale and didn't understand why this was happening in the first place, it might compromise my sense of vigilance, might freak me out. Cortisol levels, stress might be high. So that I think might be something to really examine in this one. That had these 14 survey efforts been bundled into a single environmental impact statement, behavioral impacts might have been considered, and coordinating scheduling to prevent this from happening. So thank you very much. I hope you found that informative. And you're welcome to contact us if you'd like to dig a little deeper.
Thank you so much, Michael, for sharing that research.
Okay.
We're going to go ahead and field questions for your session now.
Hi there. Thanks for your interest. Really appreciate it.
Yeah, absolutely. I'm going to navigate over to the Q&A. First question is from Richard Lovett. So can you clarify, is the problem then with the surveys and not with the final wind farms, or do we know enough about the latter just yet?
Well, this was only one element of what we're doing. We're industrializing the ocean in a lot of different ways, both with offshore oil, offshore wind, and what have you. And each one of these activities brings along with it a whole panoply of various types of noises and sounds and whatever, everything from underwater Internet of Things, communication between equipment to pile driving to seismic surveys and whatever. This was just one component, and there are a lot of people who are concerned about offshore wind because, as I mentioned in the video, it's happening really fast, and for various reasons. And this was just a component of it that before you start pounding piles into the substrate, you actually need to know what you're piling into. So they do these surveys that include benthic profiles, but also sub-benthic profile, where they find out what kind of sand or dirt or mud or whatever that's underneath where they're driving these piles. So yeah, in terms of offshore wind, I mean the next sound salad that's going to come along is pile driving, and then after that is whatever mechanical sounds, constructing on top of the piles. And I've got a paper in review right now that looks at infrasonic noise that's generated off of the turbine blades, and this is something that's actually outside of the regulatory regime, and it's actually pretty concerning because there's a lot of very low frequency energy that's being used there. So yeah, there's a whole lot of stuff. This was just like one of the introductory things, and as I mentioned, I was reluctant to get involved in it because it's very contentious, but there's a lot of data in this particular one.
Thank you for sharing that. Um, what sort of policies, oh, this is a question from Avery Thompson. What sort of policies do you think should be put in place to help mitigate these types of mortality events? I feel like we're just looking at the tip of the iceberg right now, but do you have any thoughts on that?
Well, in this particular instance, they issued NOAA Fisheries issued 14 separate incidental harassment authorizations. Any one of them individually would not necessarily pose a problem. In fact, there's a lot of scientists are saying there's no evidence that these things are actually problematic based on the IHA structure, what it presents and the regulations. But as I'm mentioning, there's 14 of those things going on at the same time. It sounds like a Jabberwocky in your neighborhood, and that might freak you out a little bit. And particularly if you're a whale, and don't understand, the reasoning behind all this noise all of a sudden. So in this particular case, my recommendation and the hearing, I guess the case is going on and trying to present legally on this is that they should have bundled these all into an incidental harassment authorization, in which case we would have been able to, schedule them out so that it won't, the impacts wouldn't be so concentrated in one particular time area.
Your example of fireworks and the 4th of July as a dog owner, I think about what we have to do, for our pets, and how we protect them when we know that there's going to be fireworks. And I hadn't really thought about how that would apply in the oceans, with this kind of work. So thank you for sharing that. We have a few more questions here. One is from Molly of ASA. Are these dB levels reaching the threshold of pain for whales? Is there any research that points to that, or is it more of a range of annoyance and disorientation?
Well, they're loud, and some of them exceed regulatory thresholds if they were longer in duration. But when we talk about equal energy levels, and how much energy are the animals exposed to? These, the baleen whales can't hear these high frequency, 80 kilohertz bursts or 40 kilohertz bursts that are being used. But the bursting itself is something, as I mentioned, you can hear this in dolphins. I have not heard this specifically. When I do my sessions, there are going to be people in the room that have actually heard this stuff, so I can verify that. But that being said, you have all these kind of squeaks and creaks and bangs going on, and you don't know what's causing it. And your habitat for the past 6 million years has been biophonic and not mechanistic, then it might be cause for alarm. One of the things that Rosa Parks and not Rosa Parks, excuse me, Susan Parks, and Rosalind Rowland did a paper in 2012 that talked about the stress levels in North Atlantic right whales that were correlated with just shipping noise, because they had a 1 week silent period after 9/11 where the shipping noise went away and the stress levels went way down. So we know that we're stressing these animals out with sounds that they're not habituated to.
Yeah, yeah. Thank you for that, and thank you for those um, references there. One more or two more questions here. One is from Richard Lovett. So these surveys are designed to find good places for pile driving, maybe later on, he presumes.
Uh, yes, that's they want to make sure that what they're driving their piles into is stable. And there's a lot of different, there's a number of different types of bases that they use, and they all have their different advantages and disadvantages predicated on what the substrate is. I mean, some of them are just gravity bases. They don't have any piles at all. But, they have to basically calibrate what's both the least costly to put in and the most stable over long term.
That makes sense. Our last question is from Hannah Daniel. Um, so I think what you're presenting is kind of tip of the iceberg. I know you're just diving into this do you think that there's any steps to get more conclusive results now that you've gotten done some preliminary um, research?
Well, on this survey thing, I think there will be, because they're doing lots and lots and lots of surveys. That at some point in time, this is something that they've been talking about in terms of the construction and operation plans, are a thing called adaptive management. And adaptive management assumes that once we see that there is a problem, that we'll adapt our technologies to accommodate for that. I'm not sure what happens when you have 80,000 jobs in a bunch of different factories manufacturing this stuff, and you find, oh my gosh, we're killing the whales. Um, so it's as I say, it's moving really fast for lots of reasons. And I've been basically working on offshore wind with my colleagues for the past 3 years now, since the beginning of the current administration. That's going to change because the next administration is going to want to go back to fossil fuel, and then the problem's going to be seismic surveys. But that being said, I mean, what our positions being is it's just, use less energy. That's the best way to do it. All these things have their own problems. We're industrializing the ocean to create energy for us to use to drive our Lightning class F-154 trucks around. So I think we need to kind of reevaluate our energy strategies, and that's going to be a challenge. And
Indeed.
we're a conservation organization that has a scientific underpinning, so that's why I'm stressing on that side as opposed to the specifics about the research.
Understood. Thank you so much, Michael, for sharing your research. Michael's session is on Thursday, November 21st, around 3:30 p.m., and the session is embargoed until then. Journalists who want to see the press release, the embargoed press release for this, can check out the link in the chat. And yeah, thank you so much, Michael. That was great.